Hello, in this video I provide a demonstration on how you can generate a regression model using Excel. Now this method is actually designed to simplify the process of regression analysis when you're actually using Excel. So we begin by developing a scatter graph that we can actually begin to have some idea whether there is going to be some correlation between the two variables. So in this particular case, I've got a data set. This data set is about data collected from Facebook. It's a very small data set, as you can see if we can actually scroll down here. But it's a very useful one. And we'll be focusing more on the hours that are actually spent online per week compared to the friends. So in other words, does the number of hours spent online determine how many friends a person is likely to be? So that's basically what we're trying to explore here. So the simplest way of beginning this work is for us to generate a scatter graph, right? So we select the range of those two variables. So in this case, friends, the number of friends is actually going to be our dependent variable, whereas the hours that are actually spent online per week are actually going to be our independent variable. So it's just a simple linear regression we're actually performing here. So now, once we've done this, we've selected the data range, then we can go ahead and say insert. And after insert, we look for the charts group. And we want to go to this the scatter graph, right? So if you hover your pointer on this icon here, you can see it says insert scatter graph. So I click on the list arrow and I select the type that I want. I want the very first one, which is scatter graph. So I click on that, and before we know it, we've actually generated the chart. Okay, and so generally speaking, we can actually begin to see that the data points do show some pattern here from left to right. Now in Excel, what we can actually do is we can actually draw the trend line, which is the line of best fit, so that we can have a much better visual experience of seeing whether the line or the data points are close enough to that particular line. So we go to the chart elements. So the chart must be selected in order for you to be able to see this. So we click on chart elements, and then under chart elements, there's trend line. So if you click on it, you can see the line is actually drawn. And then you go to that list arrow on the right side of click on it, and then you see a list of options. You want to go to more options. Click on that, and then you'll be able to see a variety of trend line options. But what we're really focused on is we want to be able to display the equation on the chart, so the linear regression equation. So Excel can actually generate it. You see, by just click on that, you see it actually generated that linear equation. Now, if this disappears, always remember to click back on the line so that you bring back that pane with the trend line options, because we want also to select the R square, which is the coefficient of determination, right? The coefficient of determination. So basically R square is telling us that 48% of the variation of the number of friends can actually be explained by the number of hours that are actually spent online, right? So to some extent, depending on the question you've actually been asked, some may just say, well, this is actually adequate. You can actually end here and say, I've actually done a partial regression analysis. Why is that so? Because you can actually use this linear regression equation to actually predict the number of friends if you know what number of hours are being spent in a week, right? So what does this actually mean? As you can see here, we can actually use this equation here. Let's say, for example, let's assume that we want to find the value of y, which is the number of friends, right? And then we can use we can use this formula here. So equal 29.926, which is the slope. And that slope is actually the coefficient. So in other words, it's simply telling us that for every change in the number of hours that are spent, the number of friends will increase by about 30, right? So 29.626. Of course, we also want to run that up because people are not in fractions, right? Okay, so basically it's telling us that. But now, what about if we were told that someone spent 18 hours? Just pick number of hours that are not included here. Let's say somebody told us that someone is actually spending 18 hours online. So we want to try to predict how many friends they actually have, right, on their network. So we can say 29, knowing that on average every additional hour will actually yield about 30 new friends. We'll say 29.626, which is our slope, multiplied by 18, which is the number of hours, closing parenthesis, minus, because what we're actually doing here, the 18 is actually represented by x on our equation. Then now this is actually our intercept. It is actually given, it's minus 7.966. Press enter. So here it does tell us that an individual who spends about 18 hours online, they are likely to have 525 friends. Right. So at least we can use this linear regression equation to, to actually predict the number of friends. So to some extent, one may say, well, that's all we want to do. We want to use this for prediction purposes. And of course, we also want to understand how strong or how much of the variation in friends is actually being explained um, by this particular model, right? And in this particular case, the number of hours, they actually explain only 48%, which means there's 52% that's not actually explained. And it's actually because of that, we are likely to say, okay, why don't we go full blown and generate a full regression statistics, right? So yes, we can actually do that in Excel as well. So what we can do is we can move this chart out of the way a little bit so that we can create some space towards the top here. Okay, move it down a little bit more. So now for us to generate regression statistics, in Excel, what we have to do is we have to go to Data tab, and under Data tab, you should be able to see Data Analysis. If you do not see it, it means that it's not activated on your computer. So there is an add-in that you're actually supposed to include so that Data Analysis will actually show up here. Just in case you haven't done that before, I can just quickly go through that. You click on File, and under File, you will see Options. And under Excel Options, you'll see Add-ins. You click on that, and then you will see, okay, it's kind of blocked a little bit here. Okay, Manage Excel Add-ins. So you click on Go, and then here you have to put a check mark on Analysis Toolpack, right? And that causes the data analysis to show up there. Okay, so now that you have data analysis, you can go ahead and click on it. And then you look for regression because that's what you want to do. Click on regression, then okay. And then we have a dialog box that is asking for what is our dependent variable. What is it that we want to predict? We know that we want to predict the number of friends, so we select that range. Okay, please note that I also included the label, right? Okay, so that it's going to be informative when we generate the regression statistics. Then what is the independent variable? And in this case, we know our predictor is going to be the number of hours that I actually spent online. You do that, okay? We just want to scroll up so that you can see the beginning of the file. Then here you click on labels to mean that the very first row is actually made up of labels, not actual data. And by default, confidence level is going to be 95%, which means we'll be testing our statistical significance using 0.05, right? Okay, which becomes our probability value. Then what about the output range? Where do we want our results to be placed? We want them to be on the same page in this particular case, right? But you could choose to put them on a separate page or in a separate file. But in this case, I want the output range to be specified somewhere here. Okay, I want the first part of the results to be placed, let's say here. And then I go ahead and say, okay, right? So before you know it, we have generated the regression statistics. Now I can move the chart out of the way a little bit more because some of it was actually kind of overwriting some of the information that I got from the regression statistics. And then what you can do here is you just want to do a right fit so that we can expand the columns enough to show all the information. Now you also notice that as part of the cleaning up, the bottom 4 columns, they are redundant, right? So the last 2 are actually redundant to the previous 2. So we can clean up by just deleting this so that we can have a much better visual experience. Delete that because it's already here. Right, so now that we have done this, we are now actually able to see that. Remember the linear regression equation that was actually generated? And I said this was actually the slope or the coefficient, and there it is, right? And of course, we said this was the intercept minus 7.966. There it is. That's how the linear regression equation is actually derived. So then using this information, knowing how many new friends are actually made for every additional hour spent online, we are actually able to, if we know the number of hours that we want to use to predict the number of friends that that individual actually have, we can actually substitute that X with any number of hours. That's how we're actually able to calculate the 525 using the illustration earlier. Now the R square, you can see the R square is the same as what is actually showing up here. Okay, now that we've got more information, we can now quickly just interpret the regression statistics. What do all these statistical elements actually mean? Multiple R is just measuring the strength of the relationship. It's at about 69%. Okay, that's relatively strong. And usually when this relationship is strong, it's likely to predict that the statistical significance of the two, there's going to be statistical significance in the relationship between the 2 variables as well. So usually it's a good indicator, right? Now, R square, we already know that is the coefficient, right? So it's actually the coefficient of variation. So basically it's telling us approximately how much, it's coefficient of determination, right? Okay, it's very important to coefficient of variation, coefficient of determination are 2 different things. So here's telling us that we can only explain 48% of the variation in the number of friends, right? Because we only have 1 variable, which means another 52% is not actually being explained here. But generally speaking, we tend to use adjusted R square, the one that takes in consideration the sample size, because the sample size could actually be having an impact on our estimates. So it's a more conservative R square that is actually recommended, right, in any form of research to be used, because you don't want to overstate your estimation. Otherwise, standard error is just telling us it's simply just showing us the data dispersion, right? There's that the data, how data is actually spread out, okay, from the mean. Okay, so otherwise observations is the sample size, and then the ANOVA analysis of variance is actually showing us the ultimate result here that the relationships are statistically significant, right? Because this number here is actually 2 6 decimal places. What does this actually mean? When you see an E and a minus, it's telling you that the value on the right side is actually the number of decimal places. So it's actually a scientific notation that's kind of abbreviating a very small number that is too many decimal places. So what does this mean? We can actually convert this right now. We can just say 0. Six decimal places. So we go with 5 zeros, 1, 2, 3, 4, 5. And then we have 8, 2, 2, 4, 2, 8, right? Press enter. You can see that it actually, it resembles exactly that. So it's important to understand what this actually means. What you're actually seeing here, you can see if you actually click on it, it is actually showing you how it actually looks, which is pretty similar to what I had here. Okay, so now because here this is a simple regression analysis, you also see that this statistical significant number is going to be exactly the same as the p-value here, right? But if there were multiple regression, then you find that this will be the combined statistical significant, whereas here then you will be able to see individual independent variables, whether they're statistically significant or not. So now down here again, additional interpretation we may actually want to do is just to interpret coefficient, right? We already know that for every additional hour, the individual will get 30 new friends. That's basically our estimate. But however, this information here for coefficient is very useful in that it's giving us additional information that because of the data dispersion, right, our estimates are within the constraint of how spread out the data is. So that's why our standard error is very, very useful in that particular regard. So it's simply telling us that while on average, right, 30 new friends can actually be created by one additional hour, they can be as low as 18 friends or as high as 41 friends. So this number is the average of those two values, right? So it's kind of taking consideration the data dispersion and the standard error for that particular matter. Otherwise, once you've done this, at least you have got a fuller picture of your regression analysis, right? Not only do you understand what a regression equation you can actually use to predict the number of friends or to predict your dependent variable, you've got more information here. It's also telling you the strength of the relationships, telling you how much of the variation is actually being explained, how much data dispersion there is, and the sample size, and of course the statistical significance, and then of course finally the coefficient. What is the coefficient, which actually give us some idea of what is actually happening every time there's a unit change, and of course what is the lowest it can be and what is the highest it can be. Otherwise, that's all I have for you. I hope you find this video useful and hopefully provide some enlightenment that you really need in order to build a much strong understanding of regression statistics. Thank you so much for watching. And again, if you like the video, share the video, and be sure to subscribe to the channel. Thank you so much for watching, and bye for now.